Yeah, hello everybody and welcome to the Python for Finance workshop. My name is Yves Hilpisch. I'm the founder and managing director of the Python QUANT GmbH. Before I give an overview of the contents of the workshop, a couple of words about myself. You find all the information about myself with regard to Python and quant work that I did and I'm doing on my website hilpisch.com. I consider myself since quite a while the Python quant. I started out with using Python almost 10 years ago for quant finance. I encountered it in a different context, but I noticed that this is kind of a wonderful language to be applied to finance and quant topics. So we founded a company back then in 2004, where we started from the beginning using Python for quantitative analysis and in our client projects. I'm also the organizer of the meetups Python for Quant Finance in London and Python for Big Data Analytics in Berlin. And I'm a lecturer for math finance at Saarland University, where I also received my PhD in math finance. A couple of words about the Python Quants, about our company. At the Python Quants, we have three main offerings. The one is the Python Quant platform, which I will introduce during today's workshop. And the other one, which is a web-based platform called Decision, which we provide since a couple of years, is a GUI-based financial engineering solution, which is very efficient in modeling kind of complex derivatives and valuing and risk managing these derivatives. But of course, we also give Python trainings and do development and consulting work for our clients from around the world, mainly in the financial centers, Frankfurt, London, and New York. The Python Quant platform, which will be introduced in some more detail, comprises a couple of, as of today, standard tools like the IPython notebook, but also a couple of proprietary things like Decision that I mentioned before and DX Analytics, a recently by us developed Python-based financial analytics library. I first introduced it at the beginning of this year, and the most recent presentation actually was at the Python for Quant Finance meetup back in May in London this year. DX Analytics, a couple of words about that, addresses a number of issues that come up when you want to model complex derivatives and want to risk manage these. It's the first of its kind when it comes to Python, where you can have even complex derivatives with multiple risk factors, and where you do have to do risk management, for example, based on delta hedging, gamma hedging, or as we see here, the vega of a multi-risk derivative. You find multiple IPython notebooks illustrating the use of DX Analytics. I can only recommend to visit the website and have a look if you're in this area, because it's, as I said, one of its kind in this particular area. I'm very proud that we recently were able to organize a full one-day conference with 2 tracks in New York City, which was called For Python Quants. 10 years ago when we started out, it wasn't even thinkable to get so much attention, but in New York we did it this year in March, on the 14th of March, actually on Friday in New York, and we had more than 200 people in attendance. I can also recommend, if you're in this space, to have a look at the website and see what talks have been given there. I'm the author of 2 books in the field. The one is Python for Finance, which is out as early release with O'Reilly. Actually, today's workshop will be based on this book mainly. I've also written another book which is more oriented towards quants, doing derivatives analytics, and where all the examples, all the models like stochastic volatility and jump diffusion models are illustrated by the use of Python scripts. This is a book that I self-published last year and which will come out probably next year and will be published by Wiley Finance. Well, I can only recommend visit the website. You find lots of information if you are in Python and quant work. But now I do want to come to the overview of today's workshop, during which we will revisit actually a couple of things that I mentioned before. Python for Finance, the overview. First of all, the workshop teaches Python from the point of view of someone working in a financial institution. And what I have in mind there is quantitative analysts, traders, risk managers, or model validators and developers working in environments that are really quantitatively oriented, like in banks, investment banks, asset managers, and hedge funds. Or people that I also have in mind are those people who consult, for example, for such a financial institution, or have to make audits and have to make sure that everything is going right there. So all these people and others benefit from the content presented as of today. The focus of the workshop lies on Python fundamentals. So of course you have to start with the basics, but before we go to the very basics, I will also illustrate first the benefits of using Python for finance by a couple of very, very specific financial examples. The approach is mainly interactive, in that we do interactive data or financial analytics sessions with Python, and mainly IPython. But all the material presented is also important when you want to build larger financial applications. So all the ingredients that you see here can be applied both in an interactive analytics context, as well as in a context where you have to build larger productive applications for a financial institution. As I briefly mentioned before, the workshop is mainly based on my new book, Python for Finance, to be published in printed fashion during this autumn, probably in November. And you will find lots of additional details and, for example, references and hints to further sources that you can use in this book. Of course, the workshop today will mainly focus on the code side and the transmission between the financial underlyings and the basics, like the mathematical algorithm description and how you come from there to the Python code. But in the book you find, again, lots of additional information that might be useful if you follow this workshop. Let me come to the first part, which is called Python and Tools, actually. This part introduces to the following topics. First of all, to start with, you need a Python environment. A Python environment means that you have kind of a Python interpreter typically, but also a number of additional libraries that you need when you want to do interactive financial analytics or when you want to build financial applications. Second, if you have installed your Python environment, then you need a development environment which supports your development or interactive analytics process. Then I will illustrate the use of Python with what I call first steps with Python. And to get a little bit more specific and dive a little bit deeper, I will also show how to interactively develop a little bit more complex function in Python. Last but not least, I mentioned a couple of Python best practices which we will try to follow throughout this workshop. Again, I will start after the very basics with some introductory financial use cases, which I consider somehow canonical in a sense that in almost any field that you work, when it comes to quant work in the financial industry, you will be faced with these issues. The one is implied volatilities, which is very important for options trading, for risk management and other purposes. The other one is Monte Carlo simulation, which is kind of the numerical method of choice, typically either for valuing complex derivatives or for risk management purposes, just to name a few, for value at risk calculations, for credit value risk, for example. And last but not least, technical analysis, but more general term would be kind of financial data analysis in general, actually. So this will be the second part of the workshop, and it illustrates the benefits of Python against the background of very specific and concrete financial use cases. Then we go to the very basics, in a sense that, of course, before you can do any analytics, you need to model data. Without data and without a correct and efficient data modeling, it is pretty hard to do efficient and good financial analytics. Therefore, it's a very, let's say, rigorous introduction into the basic data types of Python, into basic data structures like tuples, lists, and dictionaries. We will come to that. But also, of course, into NumPy data structures. NumPy is kind of the numerical workhorse in the Python world, with the ND array class, the n-dimensional array class that NumPy provides. It builds kind of the fundamental building block for all the other scientific and financial applications that we will encounter. Last but not least, a very important topic when it comes to speed and efficiency and also compactness of code is the vectorization approach that you can pretty easily and pretty beneficially implement by the use of NumPy. On the other hand, once we have modeled our data, usually one of the next steps is then to visualize the data. This is also the second part of part 3, so to say the subpart data visualization. Here the whole exposition centers around the matplotlib library, which is kind of the benchmark plotting library in the Python world. We will mainly cover here in this case 2D plotting, but also a couple of special financial plots like candlestick plots, and also 3D plotting, which might be helpful in a number of places. Just think of volatility surfaces, one of the major examples here in this case. And in the end, after having finished this part 3, we will be able to model data correctly in Python and also to visualize this data easily with the help of matplotlib. Then in part 4, which is called financial time series, we will turn to financial data retrieval, financial data management in the sense, for example, of cleaning up data, of making data or data from different sources consistent. So we will see here how we can beneficially apply pandas and use pandas capabilities, which is what matplotlib is for plotting, pandas is for financial time series management. We will again start with first and second steps. Because pandas in itself is kind of a complex and very powerful library. We will then make an exercise by retrieving data from the web actually and working with that data. But more often than not, you will also encounter cases where data is delivered as a comma-separated value file, and pandas is also very strong at that. And as of today, we have also to take care of high-frequency data and not of, for example, daily closing data. And this is the last example here in this part where we will work, or first retrieve and then work with high-frequency data. And we'll illustrate how pandas can help you, for example, with resampling the frequency of your data here. Of course, input-output operations are very important. The one thing is to work with data in memory, but most of the data, not only in financial institutions, is stored on disk or other storage mechanisms. Therefore, this part focuses solely on the input-output operations and how to make them efficient. It will focus mainly on Python specifics in the sense that it's not the focus to work with like relational databases. There is kind of a mentioning of SQLite and a couple of examples, but we'll focus on basic I/O with Python, like serialization with the pickle module. We will do I/O, efficient I/O with the pandas library, just mentioned in the context of financial time series. And in particular, we will also focus on I/O with PyTables, which is the Python wrapper for the HDF5 library. But more on that later. It will allow us to do hardware-bound input-output operations, which means input-output at the speed that the hardware you have allows. The last part of the workshop, part 6, Performance Python, is about performance issues that come up with Python. Regular prejudice of people not being used to Python is that it is slow or relatively slow, given that it is an interpreted language. But choosing the right paradigms, choosing the right implementation approaches can make Python code very efficient and very fast. But there are also a couple of very useful and beneficial performance libraries available, like Cython, for example, which is for static compiling, or parallel processing libraries like IPython parallel or multiprocessing. Multiprocessing is or comes with the standard library of Python. And we also have dynamic compiling libraries like Number or NumberPro, which allows you to compile your code to machine code, your Python bytecode to machine code at runtime, which is pretty efficient, this compiling step, and which lets you sometimes gain speedups of a factor of 100. This about the overview of the course. A couple of information is provided here with further links, for example, to the book or to the books, the 2 books that have been written.